Okay, so in this part of chapter, we learn how to represent solution of an inequation on a number line. Now, suppose we get a simple solution: -2 less than equal to x is less than 5. Okay, so this is the solution range. Numbers lies between -2 and 5. Now, there are various possibilities. First possibility is x belongs to a natural number. Okay, now look at the condition again and see which all natural number satisfies this condition. X is greater than -2 and less than 5. So possible natural number in this range are 1, 2, 3, and 4. X belongs to whole number. Possible whole number.
0.
If the same question says x belongs to integers, then
-2, -1, 0, 1, 2, 3.
okay. But suppose if the question say x belongs to a real number or rational number, okay, or x belongs to real number. In this
It
case,
will be this way.
in real number are different from integer in a way that they involve even the fraction part or the fraction numbers between complete numbers like 1.5, 1.52, 1.478. Okay. Therefore, between any two number, they are infinite real number. So even between 0 and 1, if you compare, they are infinite numbers of real number. We have real number 0.1, 0.2, 0.3, and even between 0.1 and 0.2, there are again infinite possibilities. 0.11, 0.12. Okay, between 0.11 and 0.12 also there are infinite possibilities like 0.111, 0.112. Okay, so between any two number, there are infinite numbers of real number. So we need to see how to represent this. Okay, so let's see how we represent these on a number line. Okay, we're all familiar with number line, so it's a simple. Okay, let's suppose this is a number line. On this range, on this number line, if we are, if we to represent the solution for x belonging to a natural number, we just need to represent these discrete numbers like these specific numbers 1, 2, 3, and 4. Just that. Okay. So the correct way to do that is you just darken these points, like make a solid, like a dot on 1, make a dot on 2, make a dot on 3, make a dot on 4. This is how we represent natural number. Okay. On the same number, I can show you how to represent whole number. Even these are complete numbers. So all the natural number and 0, but only the discrete numbers like these complete 0, 1, 2, 3, 4, nothing between them. So therefore, we can just include this 0. So that would show us solution for the whole number. Okay. Moving further, how to represent integers. For integers, we can include even the negative numbers. So the negative numbers required are starting from -2 to 4. So we even circle -2 and -1. Okay, so that is how we represent integers. So in case of natural number, whole number, and integer, we only represent the specific numbers with a solid dot. But when it comes to representing real number, now between any two number, they are infinite real numbers. So you cannot represent them by discrete dots. Okay, real numbers, since between any two number, there are infinite number of real number. So you need to draw solid line to represent the whole number. Okay, one way of doing that is real number between -2 and 5. So on -2 and 5, we make line. Then we put two circles here on -2 and 5, and then join the two circles. Also, we check the inequality. Okay, with -2, there is an equal to sign. That means -2 is included. So to represent that -2 is included, we darken this circle. Is this clear?
We just darken the line. Yeah, like that.
That that is also one way of representing. Even here, in this case, here you make a solid circle, and at this end you make a hollow circle. So sometimes
Yeah.
we represent on the line or we represent it above the line. Both the solutions are acceptable. We need to be careful where it is discrete numbers like natural number, whole number, and integer, and where it is continuous number like real number. Real numbers are basically continuous because between any two number there are infinite possibilities of numbers. So therefore we need to represent those infinite numbers with a continuous line and not discrete dots. Okay. Find the range of values of x which satisfies this inequality. Graph each of the following case the value of x on the different real number line for x belonging to whole number, x belonging to z. Z here means integers, and r for real numbers. Minus 1 by 3 less than equal to x by 2 plus 5 over 3 less than 31 by 6. Subtracting 5 by 3 from the entire equation or inequation, we get this. Okay, minus 1 by 3 minus 5 by 3 is nothing but minus 6 by 3, which I can simplify and write minus 2 is less than equal to x by 2 is less than. Okay, this is 21 by 6, which is 7 by 2. So from an inequation, if you subtract the same number from all the term, inequality does not change. Now, to get rid of this 2 in the denominator, we can multiply the entire equation with 2. So even if you multiply the entire inequality by the same number, inequality won't change. So this is minus 4 less than equal to x less than 7. So that's our solution. Minus 4 less than equal to x less than 7. Now we need to represent this solution on a number line for 3 specific cases where x belongs to whole number first. So whole number between minus 4 and 7 are what? 0, 1, 2, 3, 4, 5, and 6. Okay, and we darken each of these points. Okay, that's the final solution. So this is for x belonging to whole number. Next, x belonging to integers. So for x belonging to integer, we mark all these points and we also include the negative numbers. So starting from minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, and 6. And we darken each of these points. Simple. And for the last one, for x belonging to real number. In the last case, we need to include all the rational numbers between minus 4 and 7. So minus 4, we draw a line. 7, we draw a line. So here minus 4 is included, so we put a dark circle. And 7 is not included, so we put a hollow circle. And then we combine the two dots. Okay, let's see this next question. Here it's given that x belongs to integer. Solve the inequality and grab the solution on a number line. 3 greater than equal to x minus 4 divided by 2 plus x by 3. See, anyway, we are going to simplify this first. Whether separately or together, we need to simplify this. Okay, let's try this. So 3 greater than equal to. Okay, we can simplify this by taking LCM. 3x minus 12 plus 2x divided by 6. Then we multiply with 6 on either side. So this becomes 18, 5x minus 12. Okay, take 12 to the other side. 30 is greater than equal to 5x. Divide by 5. 6 is greater than equal to x. Okay, that's the first thing.
So for dividing, we don't change the sign.
Until we divide by a negative number, change of sign is not required. Only when you change sign, the inequality changes. So we dividing by positive number, change of inequality is not required. See, therefore, even yesterday I told you that simplify our steps. Do whatever you do for linear equation. Only thing, avoid dividing by a negative number. Don't cancel the negative number or don't divide by a negative number. That way your rule becomes less. Okay. Else you can do whatever you're doing for real number. Sorry, for normal linear equation. Okay. So even this part, x minus 4 plus 2 divided by x plus 3 is greater than equal to 2. Okay. Simplifying this, this is 3x minus 12 plus 2x divided by 6 is greater than equal to 2. 5x minus 12 is greater than equal to 12. 5x is So 4.8. X is greater than equal to 4.8. Is this okay?
Yes.
Yes.
Okay. So I think if we combine these two equation now, x is greater than equal to 4.8, but less than equal to 6. So together we can say that x is greater than equal to 4.8, but less than equal to 6. Therefore, okay, now also it's given in question that x belongs to integer. Okay, so we hardly have few integers between them. So we can mark between 4.8 and 6. So that is 5 and 6 only. Okay, also write 4 and 7. Okay, again 5 and 6. Clear? Okay,
Yes.
let's try this one. Let's solve it. Okay, I'll do it separately as you're more comfortable with that. So first two terms, okay, I'm writing it by converting it into mixed improper form. So minus 17 divided by 2 is less than minus 1 by 2 minus 4x. Okay, then first thing what we do, we take this to this side. Or you can take this 4x to this side and I bring this here. Why I'm doing this is, my simple logic is, let's make x positive. Okay, that's my simple rule. Let's make x positive. How? Not by dividing, by taking it to the other side. Clear? So that's my first step, or that's the first thing which I try to do. Let's make x positive, take it to the other side, it becomes 4x. Okay, then minus half, bring 17 by 2 to the other side, becomes plus 17 by 2. Simplify this. 17 minus 1, 16. 16 by 2, 8. So x is less than 8 by 4, 2. Simple. Okay, same thing on the other side. Minus 1 by 2 minus 4x is less than equal to 7.5, which means 15 by 2. Again here, I see this is negative. So I'll try to take this to the other side. This only to the other side and bring 15 by 2 here. So minus half minus 15 by 2 is less than 4x. Okay, this may not sound like a very important step, but trust me, it saves a lot of confusion. Okay, you will save yourself from the risk of dividing by a minus sign. Okay, generally we only divide by a minus number to make x positive. But if x becomes positive in this step only, then you will never have to divide by a minus sign. So that will save or prevent you from making any silly error with the division from minus number. Okay, so minus 16 by 2 minus 8 is less than equal to 4x. Okay, therefore minus 2 is less than equal to x. Correct? Is this okay? Now combine this two. X is less than 2 and greater than minus 2. So combining the two, I can say minus 2 less than equal to x less than equal to 2. Less than 2. Okay. Now we can represent this solution on a number line. So what are we including? We are including minus 2, minus 1, 0, 1. We don't include 2. Okay, let's also put minus 3 here. So minus 2, minus 1, 0, 1. Simple. The board. So let's complete this. 3x minus 5 is less than 15x plus 4. Okay, next. 4 come this side becomes minus 4. So minus 5 minus 4 is minus 9. 13 goes that side becomes minus 13. So 15 minus 13, 2x. Therefore, minus 9 divided by 2 is less than x, and x is therefore greater than minus 4.5. Okay, with a greater than and less than sign, I think you understand that the side which has two like endpoints is a bigger side, and the side which has a one endpoint is a smaller side. Okay, let's solve the second part. 15x plus 4 is less than 7x plus 12. 15 minus 7 is 8x is less than 12 minus 4, 8. X is less than 1. Okay, therefore x is greater than minus 4.5 and less than 1. So together we can say minus 4.5 less than x less than 1. let's represent this on a number line. -5, -4, and between them, like right between them is -4.5, -3, -2, -1, 0, 1, and let's extend and put 2 as well. Okay. Then how do we represent the numbers?
So we shade the regions between -4.5 to 1.
Okay. So a hollow circle here, and even a hollow at 4.5.
Yes, sir.
Okay, and then you darken it.
So we don't. 1 second.
Yeah, I was worried. I was just confused about the arrow now. Can you tell me where we put the arrow?
So not in this, but like if there's like further numbers there,
Yeah.
like example, x is more than 80.
Okay. There we put an arrow. Correct.
Oh yeah.
Yeah. Not in this case. See, when you have a boundary condition, then arrow is not required. If it is extending infinitely on either side, then we put an arrow on the respective side.
Yes.
Okay. Let's just see this question then. Okay. Let's try this together because you are comfortable with the separate term. Let's do one together. Okay. I'll do a little like I'll do slowly this time so that you could really follow my step. Okay, 6 twos are 12, 12 plus 5, 17. So -17 divided by 6 is less than 1 by 2 minus 2x by 3 less than equal to 2. Now, first thing we do is we get rid of this 1 by 2. Okay, so for that we subtract 1 by 2. Okay, so we subtract 1 by 2 from the entire inequation. So -17 by 6 minus 1 by 2 is less than minus 2x by 3 minus 1 by 2 is less than 2 minus 1 by 2. Okay, okay, taking LCM, okay, this is -17 minus 3 minus 20 by 6 is less than, oh sorry, I have written minus 1 by 2 here. Actually that cancels plus 1 by 2, so not required. So minus 2x by 3 is less than equal to 2 minus half is nothing but 3 by 2. It's 4 by 2 minus 1 by 2 is 3 by 2, correct? Okay, next, can you see all these inequation has like denominators as 6, 3 and 2 respectively, and 6 I can see is clearly LCM of 3 and 2, so we can multiply throughout by 6. That would eliminate all the denominators. You're understanding my point? See, the first term has denominator 6, second term has denominator 3, and third has denominator 2. So if we multiply the entire inequality by 6, we can eliminate denominator in each of these terms. So multiplying by 6, first term 6 and 6 gets cancelled, so minus 20 less than, okay, this with 6, 6 twos are, so minus 4x, okay, this again with 6, 9. Now, see, if we do together, okay, in order to get rid of this minus sign, the only option we have is dividing the whole equation by -4, right? Here we can't switch because there are three terms. So now the only option left for us is to divide the entire equation by -4. Okay, dividing by -4, this becomes 5, this becomes x, and this becomes 9 over 4. But since we have divided by a negative number, inequality changes. Okay, here we get a minus sign, -4. We are dividing by -4. Okay, so final inequation, if I go from lower to smaller, it is -9 by 4 less than equal to x less than 5. Now represent the
Yes,
solution on number line. -9 by 2 is nothing but minus 2.25. Okay, so on a number line, it's a number, x belongs to whole number. So whole number between minus 2.25 and 5. 5 not included, so the maximum is 4. Okay, so the whole numbers between them is -2, -1, 0, 1, 2, 3, and 4. Clear? Okay, let's see the final question for today. Okay, I'll give you a chance to just try it on your own.
Yeah, but I got the answer.
Yeah, please tell.
So x. So the solution set is x, where -4 is lesser. Yeah, is lesser than or equal to x, and x is lesser than 5.
So -4 to 5.
Yeah.
Okay,
So -4 is included, so it will be a like a whole circle, like it will be a filled circle, and but at 5 it will be a hollow circle.
it's a hollow circle.
Yeah.
So it's like this, how you represent mostly. Okay, all right then. I think then that's fine for today. We'll end our class here. See you again in the next class. Thank you and bye for now.